Okay, now we can move on to the plotting of 2D graphs. So in 2D graphs, we have x-axis, and y-axis. And we have the origin here. So for an example, let us consider y equals sin x graph x between minus pi plus pi. So we want to draw that. We know from from our calculus knowledge the shape of this graph. So the sin x graph goes like this. I'm sorry for my poor drawing, but the shape is basically like this. Yes. Okay. So can we plot this in Python? So to do that, just like we imported the NumPy module for numerical analysis purpose for the plotting of 2D graphs, we import some other module called matplotlib.pyplot. So we first import that. And we abbreviate it as PLT. We also import the NumPy module, NumPy as NP. Okay, now it has run. Now, next we generate some x values between -5 and +5. Create a vector x which contains values from we create a vector x which contains values from -5 to +5 with a step of 0.05. So which numpy function are we going to use for that? What is the easiest one? np.array? No, np.array would be really hard. np.arange. Starting point minus, it's -pi. So we import the value pi from the numpy module. So minus np.pi. So pi is from the numpy module. np.pi. So the last, the ending value is np.pi. It's the positive one. Step size is 0.05. Print x. So we generated some x values. We generated a lot of x values. We can use x dot size to check how many values we have generated. Here, in fact, we generated many x values from -pi to +pi. Okay. We want to check the size, how many points we have generated with frame x dot size 126 points. So here we have 126 points. Now, please note that this blue color graph is obtained from our knowledge of calculus. Not from Python. Okay. Next. Now, for these 126 x values, we need to get the sign value of them. So we get that y equals, we import the sign function from the numpy module. So np.sign, not just sign, np.sign x. For all the x values, we are finding the y values. Okay. Print y. So how many y points are here? Same number as the x number of x points, 126, because we generated the sign values for all the x values. Okay, now we want to plot this. Now remember we imported the matplotlib.pyplot module as PLT. So we use the PLT module to plot this y against x. PLT.plot x comma y. X values and y values. PLT, we also write PLT.show. Okay, now this graph, the Python plotted graph, is the graph that was plotted from all those x values and y values. So 120 x values are here, and 126 x values are here. For those x values, 126 y values are here, and those x values and y values are plotted. So we obtain the same graph, same shape from connecting the dots of 126 points of the y equals sin x graph. The shape is similar to the shape I have drawn from my knowledge of calculus. Okay. So that is how we draw plot graphs on Python. Now we can add different things to this graph. We can add title and X label, Y label, legends. We can adjust the font size. We can add a grid. Yeah, we can do those things. Now we will move on to see how it's done. Let me clear my handwritten drawings. Okay. So now I'm going to plot the graph in green. How do I do that? So let me copy and paste this code. So plot xy, comma, g. G is for green. So this will plot the graph is plotted in green. Graph is plotted in green. We will see gives us a beautiful green graph. Okay. Next, I want to I want a dashed line, not a solid line like this. So let me copy and paste this code. So I want to plot the graph in green. Not only should it be plotted in green, it should be dashed like this. Okay, now we see that the graph is plotted in green color with a dotted dashed line, not a solid line. Okay. What if I want to plot it in blue color, not green color? I can do that. So I mark this as B. So it will be plotted in blue. The symbol will be star. So I want it to be plotted in blue color with star marks, not dash line or solid line. Graph is plotted in blue. Okay. Hmm. Now you can play with that. Let's say I want to plot it in a different way, in red color. The symbols will be star dash. If something went wrong, I think the error is you should not have a space. Yes, star and dash. All right. Now let's go further. Let's plug this in the usual way. I think it's blue color, solid line. Yeah, this one. Now, I want to add a title to this. So under the PLT plot, I write PLT.title. PLT.title within brackets. Y equals sin x. Y sin x. So this gives a title for the graph. Here's a title for the graph. See, it's a title. Y equals sin x. Now I want to give the x label. How do I give the x label? plt.x label. plt.x label. What is X label? It is angle in radians. Angle radians. I think it should be angle in radians. It gives an X label. Angle in radians. This is our X label. Next, I want to give a Y label. PLT dot Y label. What is the Y label? It's sin X. In of X, it will be this gives a Y label. See, sin X, Y label. Next, I would want to give this a grid, give this graph a grid. PLT dot grid. PLT dot grid. This gives a grid. See, these boxes, grid boxes are here. Next, I want to give the legend. PLT dot legend. Legend. What is this graph? This is y equals sin x graph. So I write within square brackets sin x. This specifies the graph. See, sin x. The blue color, this says to us the blue color graph shown here is sin x graph. If there is some other colored or other symbol graph, it will specify that graph. Okay. Next, I want to change the font size of the title. I want to make it bigger, make it look big. And what is our title? This one is the title command. I change it to font size 20. Within curly brackets. Size 420. Adjust the font size of the graph. See now, the font size is bigger. Y equals sin x is bigger. Earlier it was a small title. Now we have a big title. Next subtopic, plotting multiple data sets. So let me recall what is my set of x points. np.a range, starting point. Now let's take a bigger set, from minus 2 pi to plus 2, from minus 2 pi, np.pi to plus 2 np.pi. The step size is 0.01. 0.01. Now I plot multiple graphs. Let my first graph be y1. Let that be sin x. np dot sin of x. Let my second graph be y2. Let that be np dot sin, not x, but x minus pi by 2. Shifted by pi by 2 gradients. X minus pi by 2. np dot pi divided by 2. Let my third graph be y3, it is np dot sin. It is shifted even further. It is shifted by pi radians. np dot pi, sorry, x minus np dot pi. Now I plot these three graphs on the same plot. Here t dot plot x comma y1 comma x comma y2 comma x comma y3. plt dot show. Okay, now three graphs are plotted in three different colors: blue, orange or yellow. I think it's orange, and green. Okay, now can we identify which graph is which? Can we identify the y1 graph? Y equals sin x. I think it is when x equals 0, y equals 0. Okay, this blue graph is the y1 graph. And yellow or the orange graph is the x minus pi by 2, sin x minus pi by 2 graph, because it is shifted by pi by 2, and the green one is x minus np dot pi, x minus pi. Okay, now that we have identified it, we can put a legend and make it look nicer. Let's put a legend. Put a legend. plt dot legend. plt dot legend within square brackets. The first one is sin. The first graph. What is the first graph? X, Y, 1. The first graph is sine x. The second graph is, what is the y2 graph? It is sine x minus pi by 2. The third graph is sine minus pi. So this will give a legend, nice legend. You see, blue color is the sine x graph, orange color is the sine x minus pi by 2 graph, green color is the x minus pi graph, sine x minus pi graph. It looks good. Now the next method is the method 2. Which is the method 1. This is the method 1. But in multiple data sets, method 1. Now I'm going to show you the method number 2. So, instead of writing everything in one line, I break it into segments. PLT dot plot xy1, x comma y1. PLT dot plot x comma y2. PLT dot plot comma y3. So by this way, we plot everything on the same plot. We also add the legend. I'll copy and paste it here. Legend and PLT.show. Okay, the same graph is plotted in the method number 2. Next is the subplot. Instead of plotting on the same space here, can we arrange 3 different spaces for three different graphs? Subplots. So let me begin. Let me start from the beginning. Okay. Now I have my x values and I have my y values. So I have to plot 3 different graphs in 3 different spaces. So let me say. Okay. Now let's say this is my space. I want to break it into 3 equal spaces like this. So my first graph should be plotted here. Like this. This is xn y1. The next one, I want to plot something like this, x and y2. And the next one, I want to plot here in the third space. The axes are x and y3. So can I do that? I can use in the subplot function. plt dot subplot. Subplot. Yeah. Now this is like a matrix here. So this is the first row, and this is the first column, second column, third column. So this plot I would say so this space is no, forget about it being a matrix something. This has one row and 3 columns. And here, this space we call it 1,3 space. 1,3, 1 space. This space we call it 1,3, 2 space. This space we call 1,3, 3 third space. Okay. Now we want to plot this first graph xy1 at the 1,3, 1 place. So subplot place 1,3, 1. Please plot plt dot plot xy1, y1. plt dot subplot 1,3, 2 space at that space plot plt dot plot xy2, x, y2. Third space plt dot subplot 1,3, 3 at that space plot. What should I plot? X, y3. plt dot show. Now let's run the code. Oh, okay. Yeah, just like I wanted, it has plotted the 3 graphs at 3 different places. Okay. So if you want, you can change the colors according to your preferences. So that also is fine. So that is the end of graph plotting, 2D graph plotting. And we can also see a little, you can have a look at the bar charts. So let me take a set of x points in p dot a range, sorry, in space. I want numbers between 0 and pi. In p dot pi. I want 20 numbers. I have 20 numbers. For these numbers, I want the sign values, y equals np dot sin x. Now I have my x values and I have their y values. I want a bar chart. Here d dot bar, not plot, it's bar. X comma y. Here d dot show. I get a nice bar chart. How about pie charts? Let me take a set of the x points. X equals np dot array. Five, 15, 25, 55. plt dot phi. So use the phi function for the x vector. plt dot show. Okay. So why don't we have y values for these x values? So it doesn't make any sense because unlike the xy coordinate graphs, where we plot something on the y graph against something on the x graph, the meaning that we get from pie charts are different. So here, here actually we want to compare an array of values. We want a visual interpretation, how big each value is compared to the percentage values. So here we have values 5, 15, 25, and 55. So if we add them all up, 5 plus 15 plus 25 plus 55, what value do we get? 20. Okay. 20, 45. Oh, it's 100. Okay. Now this, what are the percentage values? 5 divided by total multiplied by 100%. Here, 15 divided by 100 multiplied by 100%. 25 divided by 100 total. 55 divided by 100 multiplied by 100%. So this is 5%, 15%, 25%, 55%. Okay. So this graph shows these percentages. So this is 5%, 15%, 25%, 55%. that is how we plot the pie charts. So so that concludes my uh, session on graph plotting. So I think you got an idea, introductory idea to what it's like to plot a graph on Python. And please also remember that this is a basic introduction, but you can go into detail by using actually there are a number of web pages where it explains how to use how to plot graphs, how to plot different types of graphs. With this basic understanding you have in your mind, you can actually Google and go into detail and look up many details on the graph plotting. So I think this is a good session. Let me save the session. I'll also make a PDF of this note, and I'll also upload the Colab notebook, the program code, together with the video. So the note and the code can be found under the description of the video. So you will be able to run each command of the code while you are playing the video. Okay, thanks for watching.